Hello everyone, it is April 14th and this is 7th and 8th grade science class and we are starting on page 37 and my book's way over here again. So we're starting on page 37. Yesterday, of course, we began looking at all the structures that are on a flower. We tore apart a poor little tulip and we looked at its pistil, which contained its ovary and its style and all of those top things that we looked over. I'm just looking, you can look on what I'm doing. That if you look on page 35, you probably had parts of a flower back in 5th and 6th, maybe 3rd and 4th grade. But we looked at the pistil, which is the stigma, the style, and the ovary. We also looked at the stamen, which contains the anther and the filament, and we took apart a tulip to look at that. Today, on page 37, we are actually starting pollination and fertilization. Before we get started, let's go ahead and say a quick word to the Lord in prayer, and then we'll look over your lesson today. So, Heavenly Father, we praise you and thank you for giving us such beautiful creation that we can learn more about through science class and for just, by just walking around and looking at your creation. And Father, we also want to give you praise and glory for just loving us enough to come and sacrifice your Son for us while we were still sinners. And we just give you praise and honor and glory for that. And Father, be with us, keep us safe, keep us well, give wisdom to us, give wisdom to the leaders of our country. We love you in Jesus' name, amen. All right, so starting back over on page, what page is this? 37. We're going to start looking at pollination and fertilization. Pollen is useless to a flower unless pollination and fertilization occur. And of course, this time of year, there's all kinds of pollen, but it's going to occur, unfortunately, throughout the growing season. You might not realize, but one reason why a part of the Appalachian Mountains are called Blue Ridge Mountains, that bluish haze, or even somewhat contributing to the Great Smoky Mountains, which are part of the Appalachian Range, is pollen. That's one reason why that contributes to it. So pollination is the transfer of pollen from the anther that we looked at yesterday to the stigma, which is the top part of that pistil. So fertilization is the uniting of a sperm from a pollen grain with the egg that's inside the ovary, which once again is at the very bottom. So this leads to the formation of a seed, and both pollination and fertilization are crucial in the reproductive cycle. And of course, you all have eaten enough fruit to know that basically the seed is contained within the fruit. So what would the fruit be that I'm actually eating? That technically would be the ovary of the flower that's growing, and it's all good, right? So both pollination and fertilization are crucial in the reproduction cycle of a plant. Without pollination, the egg cycle could never be fertilized, and without fertilization, a seed could never be formed. And because of that, God has designed all kinds of creatures and all kinds of different methods of pollination. For example, daisy pollen cannot pollinate a sunflower. Obviously, that'd be really weird. And so he made sure that, because you got all this pollen blowing in the air, you didn't want some daisy sunflower. So he makes it very specific. And then he creates wind, he creates birds, he creates maybe people, and he created bees to help in this pollination process. When a plant's pollens mature, the anther will open and it will expose the pollen grains. And even yesterday when we were playing with the anther, you could see on my finger I was getting like some yellowy stuff from the tulip anther. Wind may help carry the grains to that sticky stigma at the top. Insects like bees, moths, ants, bats, some birds, all of those can be potential pollinators because they also aid in pollination. Most pollinators, remember, were drawn to the flower because of the color or the shape of the petal, and maybe to the flower scent or its nectar, which is the sweet liquid usually stored in the base of the blossom pretty soon the honeysuckle should be blossoming. I've not seen any yet. This one, I have a bunch of honeysuckle around my house, and I've not seen any. But that's those Japanese honeysuckle, which really is not a native plant. It's from Japan, and it's rather invasive, but it's really sweet and good. And it normally has yellow, and it has white blossoms on it, and you can pick them. You can pull off the little sepal at the bottom, and you've got a little drop of really sweet nectar, so that you can get from it. Now, and that's kind of how the bees make their honey and those type things. So that's what's attracting these pollinators. While pollinators are collecting pollen and nectar to use as food, or for a bee for making honey, some of those pollen grains also stick to the animals, and they carry them from plant to plant. And one thing that a lot of farmers are being really concerned about is our native honeybees are really endangered. And even when the people who, just went out of mind, aviarists, what are they called? Honeybee people? Anyway, people who grow honeybees and to produce honey, they're even having a hard time with their own bees. So we need to plant flowers, be careful of the little honeybees. My sister has honeybee hives, and I've worked in her vineyard with the honeybees swarming all around me while we're trying to pick grapes. A normal honeybee is not that aggressive at all. They just normally crawl all over you. Unless you mash it or, actually aggravate it, they're not going to sting you as aggressively as a wasp. So, moving on, it's interesting to see the many ways that God provides for each plant to be pollinated. For example, the stamens on alfalfa blossoms stay curled up in a bud and undisturbed until an insect will actually seek the nectar, and as soon as it touches the bud of the alfalfa blossom, it triggers a mechanism that causes that stamen to rapidly uncurl and release all the pollen grains. There is such an excess of pollen that normally that flower can undergo self-pollination, which means there's so much pollen that comes out of that mechanism that it pollinates it can pollinate itself. Many insects will actually avoid alfalfa blossoms because of that pollen shower, but that doesn't seem to bother leafcutter bees or other types of alkali bees. One brain bite, and you already know this, most pollen allergies come from wind-borne pollen grains, which includes plants with bright showy flowers, which are usually pollinated. Those do not cause the that doesn't cause, you're not allergic to honeysuckle. You're not allergic to like a showy flower, like a real pretty bright colored flower, because God made those flowers so colorful, so bees and other things will be attracted to them, and he uses that to pollinate them. So it's normally grasses, ragweed, things like that. Lots of people say they're allergic to goldenrod in the fall, and goldenrod really doesn't produce that much pollen either. It's normally ragweed that they're confusing it with. So once an alfalfa flower has been pollinated, its blossoms quickly lose their scent, which thus encouraging the bees to travel to a fresh alfalfa blossom in search of nectar. And as the bees activate that trigger mechanism on new alfalfa blossoms, they deposit pollen from previous flowers onto the stigma of a new flower. And that transfer of pollen from one flower to another, so not from the same flower, not going from that one flower's stigma or anther to its to the pistil or to the stigma, is actually coming from this flower to that flower. That's called cross-pollination. Hold on. All right, so just had a text from Mr. Clark. Just wanted to check and make sure I didn't need to do something right away. So once a pollen grain attaches to the stigma, then something wondrous happens, or something weird happens, however you want to think about it. The pollen grain actually starts to grow like a little seed. Only a pollen tube begins to grow from the pollen's location on the stigma, and it travels through the style into the ovary. The sperm cell, or the male reproductive cell of the pollen grain, then divides into divides to form 2 sperm cells, and the sperm cell then moves through the pollen tube, and one of them unites with the egg cell, which is the female reproductive cell, in the ovule, and that causes fertilization. The other sperm cell helps produce food storage tissue that the developing plant will use later on. So the fertilized egg, the egg cell, and the sperm cell combined and fertilized divides, and it's what actually forms the embryo, which is the beginning of a new plant. So each seed is basically a powerful growth package with 3 main parts. They've given you a picture of 2 types of seed right down here at the bottom, both the monocot seed and the dicot seed. Some of your families grow gardens. My family does that as well. And 2 crops that we grow normally are corn, because we like sweet corn to eat, or green beans, because we like green beans. So that's monocot and dicot seeds are right there. So hopefully if you have some of those, or if you can get some from grandma and grandpa, you can do a cool experiment that's here. Maybe you can do it on your own. So when a sperm cell unites with an egg, the resulting embryo is a miniature plant made up of a plumule, and that tiny shoot will become the stem and the leaves, and a radicle, the small root, that will develop into the root system. And then you have 1 or 2 cotyledons, that structures that design for food absorption and storage. The cotyledons will, cotyledons will, I keep losing my place. The cotyledons absorb stored food from the endosperm, and then the protective seed coat must be softened by moisture in order for that embryo to go through the process of germination and then be able to actually grow. And that's one thing I thought would be really cool if you did. Well, it's toward the end of this chapter, not this chapter, this section that we'll look at it. Okay, getting text bombed here. I think everyone is just agreeing. Yeah. Okay, so plants whose seeds have 1 cotyledon is a monocot. And monocots, we'll go into far more detail about them later. Normally they have a different vein structure in their leaves. They have a different seed structure. They're normally like grasses or corn. Corn is probably the biggest garden monocot. Grass is a monocot. And then you have beans, and most everything else is dicots. And dicot simply means they have 2 cotyledons. In most dicots, the endosperm is completely absorbed and digested by the cotyledons before the seed exits the parent plant. In the monocot, the absorption of the endosperm takes place during germination. So dicots like beans, peas, and peanuts generally germinate faster than a monocot, which would be like corn and wheat. And I know this, give testimony about this. You can plant your corn, you can plant your beans at the same time. The beans seem to just pop up within a few days. They get a little bit of moisture, they get some warm sun, and your little bean seed is just popping out. Your corn normally takes a couple of weeks for it's actually, deciding to do something. And that's a cool experiment you could do. You could get some bean seeds. You could get, which are dicot, you could get a grain of corn, or a kernel of corn, and you could, which is a monocot, and put it in some soil, and then you could just do your own experiment. Which one's going to germinate first, or which one am I going to see grow first? The Creator supplies the embryo with an ample food supply, or starch, to keep it alive until it germinates and develops leaves to make its own food. When you eat a seed, like a corn kernel or a bean, you are getting the nourishment that embryo would have used if it had actually germinated. And God provided that nutrition as a source of food for people and for animals. We also use plants for medicines, for clothing, for shelter, bunches of stuff. As well as when, I had something that came in my brain. We learned in health, of course, that corn is not considered this vegetable. Corn is considered a grain due to the fact that it's a monocot, whereas a bean is a vegetable, but it's technically a legume. It's in the same family as peanuts and peas and things like that. They're legumes. So going on down to fruit. So after fertilization, A flower fades and drops its petals, and then the ovary where the seeds lie hidden becomes larger and larger as the plant develops a supply of food around the seeds. When the ovary is fully developed and ripened, it is the fruit. And there's all kinds of things, where we're actually eating seeds, when we're eating beans and when we're eating corn. If you've ever looked at a strawberry, strawberries to me are the coolest thing to watch grow because they have a little blossom, and basically the strawberry is the very, very center of that blossom. You can actually just see it start to grow, and it's kind of different because all of its little seeds are on the outside. So that, so if you have a strawberry plant somewhere around you, you can just maybe look at it. The strawberry should be getting ripe within about a month or so here locally. So maybe you can actually see one of those. There are such things as wild strawberries as well. So scientifically speaking, a fruit is the ripened ovary of a flower. It's not always edible. A fruit may be many times larger than the original ovary. Nuts, grains, olives, those are some, and common vegetables like tomatoes. Tomatoes technically isn't a vegetable, it's a fruit. But string beans, cucumbers, all of those are really edible fruits. Milk pods would be an example of an inedible fruit. Skipped over the brain bite that they had. The largest seed is the coco de mer, which is a double coconut palm, and that seed can have a circumference up to 56 inches and weigh up to 66 pounds. That's a big mama seed. All right, so if you want to turn over to page 39, your experiment, if we were here, we might have done this, was like with starches. This is like a starch search looking in seeds. They've also given you on page 39 a diagram of what an ovary would look like in the blossom, developing into a tomato, what the ovary would look like for an orange, developing into, from the ovary of the flower to the actual mature fruit of an orange. We are going to go on over to page, on over to page 40, just making sure I'm keeping my schedule. So the world's largest recorded pumpkin, this is as of 2016, was up to 2,624 pounds. I wonder if that's one that was at the pumpkin festival. I don't know. So fruits are designed to protect the maturing seeds and to help with the dispersal or the spreading of seeds after they have matured. If seeds were not spread over a large area, they would be stunted from competition with each other, and the type of fruit determines whether those seeds are scattered by mechanical dispersal or by agent dispersal. Now, mechanical dispersal is super, super cool. It occurs when the ripened fruit will actually burst open and scatter the seed from some distance from the plant. And we have a really cool plant that grows along our creek here at our school. You probably have it somewhere. It's a common wildflower, but it's normally mature about the time, well, I said about the time we come back from school, but it's normally September, mid-September, somewhere in there. And it's called the jewelweed, which is a type of impatient. So if you have impatient flowers, that is a type of, they use mechanical dispersal, just your regular impatiens as well that you just have growing in a pot at your house. But the jewelweed is an actual wild impatient. And what happens to the jewelweed, you can see right here. That jewelweed is what has been, the ones we have here are really bright. They look like a little trumpet, a yellow, a orangey trumpet. Let me see if I can find one real quick so you can look for it later on maybe. Okay, so jewelweed flower. Whoops, not glower, but a flower. And the ones we have typically are orange. And okay, so this one is, oh, I did not want Etsy. Click the wrong button. So I'm looking at images here. And that one's just giving me, and they're typically called touch-me-nots. Right, this is giving me things that look like that. But what I'm looking at are flowers that kind of look like that right there. Or as we go on up, something, they look something like that. But this is, of course, I clicked on Etsy again. It's wanting me to buy one. they grow naturally here. They're all the way around. It's a natural plant. And those little flowers, when they get to a point, they make this, when the flower sheds, or sometimes when the flower is almost to the point of shedding, they develop a little thing that looks like that. And that's why the jewelweed quite often is called a touch-me-not. Some impatiens are also called touch-me-nots, or they make those little pods that look like that. And you will touch them, and they burst, and they end up looking like that. But in the process of bursting, they have shed their seed everywhere. I've bought impatiens just from the greenhouse before. They're not a native plant, and especially this past year, the impatiens I bought, some of them, by the time the end of summer happened, I had some growing on the edge of our gazebo, and they had burst so many flowers. I had flowers growing all along the base of my gazebo, not on, because my pot was sitting up on the gazebo. It burst and it went to the soil over the railing, and I had impatiens starting to grow there. That's just mechanical dispersal. Now, other plants will use agent dispersal, and that would be like birds and animals and people. It could be the same way. So birds and many other animals become dispersal agents by feeding on a fleshy fruit, like a blueberry, raspberries, and blackberries, and then those seeds do not process through their digestive system. Cattle is the same way, where they feed cattle corn, and the old adage was like, why did the farmer feed the cattle corn? It's because it fed the chickens too, because the corn just went right through the cattle system, and then the chickens would come pick it out of the cow's poop. But I've actually had this happen. We have wild raspberries growing on our property, and we actually had the wild raspberries growing on the opposite side of the road, which was still part of our property, so we weren't technically stealing from the neighbors. And the birds would eat the raspberries on that side, and I guess would come over in some trees over on the edge of our yard and digest and poo there. And we actually had raspberries starting to grow on the other side of our property, like right in front of our house, which we like raspberries, red raspberries, so we just let them grow. Wherever there's a raspberry briar, it's staying there, because we just like raspberries, and we figure the more briars we got, the better. But we didn't have to plant them. The birds planted them for us. So birds will eat them, and then they'll fly off, and then they'll poo, and you got a new seed. And it's got fertilizer that it can grow in. There's also other ways in which animals will act like an agent. The biggest, probably walnut planting animal we got is squirrels, because they'll take those walnuts and they'll bury them, but they can't remember where they buried them. So what happens? A tree starts to grow. And it's not just that. It could be acorns, it could be anything. Some animals, they'll brush along something. You may have been an agent yourself if you brushed along and you had a cocklebur, or what some country people call beggar lice. Those are seeds that have grabbed onto you, or dandelion seed might grab onto you, and then you scatter it as you walk. Wind can also act as agent dispersal. Many seeds have all types of equipment on them that allow the wind to pick them up and carry them far away from the plant. That's like a milkweed seed, a dandelion. But what you might remember is, and you'll see them here next month or so, the helicopter things that the maple trees produce. They look like they're hanging off the maple tree. I remember getting them, and you fling them up in the air and they'll kind of helicopter down like that. So that's getting ready to be produced here pretty quickly. Other seeds will find some suitable places in which to grow, and they're often transported by a stream or a river or even an ocean current. A coconut is the fruit of the coconut palm, but it's really a very large fruit, and it contains air spaces inside it, so it can float along the ocean. Coconuts may travel on the ocean currents for several miles. The seeds of many waterborne coconuts eventually will get soaked with water and die. However, some coconuts will be washed up onto warm beaches where their seed can actually sprout and then grow into a new tree. So that has finished your lesson. We've actually gone a little more than I thought. If we hadn't had to stop, we aren't doing the activities, so we can cover a little bit more of our chapter this time. So this, like I said, again, is for April 14th. I have sent home at least one activity that shows the diagram of the flower and another quiz with you for this week. So have a good day, and I will see you. Your next lesson will be on Wednesday, April the 15th, and that will start on page 41. So have a good day.